Okay, so let's talk about OR configurations or OR building. And the idea is as follows. Here's our 2-channel wire, and this is our program channel, and this is our control channel, and this is our target cell. And we can easily configure this cell, we can easily configure this cell, and we can use this cell to configure a remote target. So target 2. And how do we do that? Well, for example, first we configure this, and then we configure this, and then we configure this in whatever way we want. And our configuration sequence looks like this. Step 1, control channel equals 1, program channel equals, and we'll say data routes from west to east, and the eastern cell is in control mode. 2, set the control channel equal to 0, set the program channel equal to whatever we wanted this cell to be. And then 3, return the control channel to 1, program channel equals whatever we want that to be. Okay, so what happens in these 3 steps? We turn on the CC line, so this cell goes into C mode. We load in this program which says take data from the west, send it to the east, and put a 1 into the eastern cell's western C input. So now we're telling this to put this cell into C mode. That doesn't happen until we return the control channel to 0 and we take target out of C mode. When target goes into D mode, its C output can be asserted, and that will put target 2 into C mode. So in step 2, we've basically put target 2 into C mode, and we're sending some truth table through target into target 2, and we're configuring this cell. Now at this point, every clock cycle tick, whatever bit is on the D line is getting loaded into target 2's truth table, and the previous value is being overwritten. If we go away at this point and we stop sending bits through target, eventually that truth table that we've written will be zeroed out, assuming we're not putting anything except zeros onto the D input of target. But in step 3, what we do is we put a 1 on the control channel, which puts target back into C mode. And as soon as target goes into C mode, its C output is forced to 0. So at that point, target 2 leaves configuration mode, goes back to D mode, and its truth table is locked in. That works great. So that's how we can configure something that's 1 spot removed from a target. But when we want to move 2 spots away, it gets a little more complex. So in that case, here's our program channel, here's our control channel, here's our original target, here's target 2, but let's say we want to configure target 3. And when we first introduced wire building, we talked about doing this Towers of Hanoi type approach, go forward, go backward. And there's actually a problem with doing that. And the problem is as follows. We might naively think, first we're going to configure this target cell, and we're going to use it to configure target 2. And then we'll come back and we'll configure target 3 in some way. And what we're going to do is in step 1, control channel equals 1, PC equals, and again we'll run data from west to east, and we'll assert the eastern C output. And then in step 2, set the control channel to 0, and we can put whatever configuration we want into target 2. So the first thing we might try is just put in the same configuration. Right? Let's set up target 2 to prepare us to program target 3. So this would be our second configuration, and then in step 3, we reconfigure target and we set it up to just pass data from the west to the east. So far, so good. At the end of step 3, what do we have? We have a line passing data from west to east. We have target 2 passing data from west to east and asserting a 1 into its control east output. Target 3 is going to be in C mode, and it's receiving bits from the D output of target 2, which is coming from the D output of target 1. So in step 4, we can return the control channel to 0, and we can set our program channel to whatever we want target 3 to be. And at the end of step 4, the truth table bits that we just loaded through this D input on target's western edge will be loaded into target 3. So 4 will be successfully configured and will be in its final configuration state. The problem comes in how do you undo this? Because at some point we need to change target 2 so it's no longer asserting its C output. And the only way we have right now to do that is to reconfigure target to look like configuration 1. So step 5, control channel equals 1, program channel equals this. And so in step 5, we begin to configure target. And our goal again is to take target 2 out of C mode, out of its state where it's asserting target 3 into C mode. The problem is when we're doing step 5, target 2 is still asserting its C output. And in step 5, target 3 is going to get zeroed out because we have zeros coming in because target is in configuration mode, its D outputs are 0. We can't afford to send target 3 bits through target's D line because we're using that to configure target. So target 3 will be receiving zeros on its D input, but a 1 on its C input, and so it's going to zero out target 3, and we lose the truth table that we just loaded in there. So this is a problem, but it's not a huge problem. There's a pretty easy way to deal with this, and this will be the next video, is how to solve this or configuration problem.